the introduction. Hello, everyone. My name is Marcus, and I am the Technical Sales Specialist for DS Lab Global. So following the structure and product introduction of the DS2 AI, the automated MLOps solution that was held earlier, this talk will introduce the value and technology of DS2 AI, focus on the data-centric model and the value of data and its impact on the machine learning-based solutions. So before explaining the meaning of MLOps, I will briefly explain why MLOps came about. So currently, many data scientists are joining the company as data scientists in anticipation of writing artificial intelligence development code or machine learning code, as you can see in this diagram. So, but however, of the tasks given to them, the time spent actually writing the development code is only a small part, and most of the time they collect, pre-process, and verify the data, which can take a tremendous amount of time. And for the model to be implemented, they spend a lot of time building an environment to utilize and monitor this. So the overall system for the data collection stage to the operation and management of artificial intelligence models after development is called MLOps. Unlike DevOps, where developers are involved in operations, MLOps is a specialized operation for artificial intelligence models. Therefore, the AI service with such MLOps system is clearly distinguished from the service without it. So if there's no MLOps system as shown on the left side of this slide, even if you create an AI model once and create a system that utilizes it, in order to improve the AI accuracy, you need to collect data, process it, create the artificial intelligence, and then deploy it. So it takes a lot of work because the following things have to be made from scratch again, and above all, the biggest problem is that there's no one who specializes in this. And because data scientists are focused on artificial intelligence development codes, they lack skills or experience in designing and building the infrastructure. And data engineers and backend developers who are good at building infrastructure or backend system, they don't really know how to redesign them. Conversely, just because the AI model is deployed once, it does not mean it ends there. To improve the AI accuracy, the AI inference data is put back into the data set, and the data set is labeled to make the training data in a form that can be retrained and can be quickly created and redeployed. So in order to build these reusable machine learning pipelines properly, you must have a good understanding of the model lifecycle governance. First, you have to set what business goals you will achieve with the artificial intelligence model you want to create. Paradoxically, it becomes clear what data to collect only when it is properly set up. If this process is not clarified, it would be good to consider it as one of the most important processes, because the machine learning system itself needs to be rebuilt from scratch. In fact, it's almost impossible to set it well from the beginning without any experience, because there are so many cases of revising goals due to the facts that you learn while you're working on a project. Second, when you decide what data to collect to create an artificial intelligence model, you collect data and label the data if necessary. Then the artificial intelligence model training is performed using the machine learning algorithms. After training the model, you need to check if this model is well made through the testing process, hyperparameters necessary for training. And there are so many deep learning frameworks these days, so many codes, they must be developed in order to create more accurate artificial intelligence. After creating the most accurate artificial intelligence model through model testing, artificial intelligence is deployed and used by connecting it to the service. And through continuous monitoring, the service model checks whether this model is operating normally and whether the service is operating at a level similar to the test results. So it can be seen that the machine learning pipeline is the actual systemization of the model lifecycle governance. And there are two main branches here. In MLOps, there is an MLOps solution that focuses on model improvement called model-centric. In the case of our product, DS2AI, it is data-centric MLOps, which focuses on automatically building this machine learning pipeline. So the reason why we chose data-centric method is extremely simple, and it's because we can develop higher accuracy model with the same development time consumption. Starting with a study published in March this year at the session of Stanford professor and machine learning master Andrew Ng, the importance of data itself began to draw attention in the machine learning based solutions, and these have been undervalued for some time. Andrew conducted a thorough numerical analysis with his team, and if you look at the data together, you can see that the steel defect detection test, which was the core test of this research, showed a whopping 17% increase in accuracy. And other tests show that the data-oriented improvements were more effective than the model changes as well. So in summary, it is much more effective to refine and improve data rather than to change the structure of the existing codes or the models itself. To briefly look at the steel defect detection, which was able to improve accuracy by 17%, the impact of product defects in the distribution market is reduced only when the defects that can occur in the steel sheet manufacturing process are almost completely detected. And at this time, about 76.2% of the baseline system could be manufactured using the finely adjusted hyperparameters, but this was far from enough to completely detect the defective products. The baseline model has already been made well, and it seems virtually impossible to achieve accuracy above 90%. However, with the data-centric method, it identified the discrepancies and organized problematic labels, and then the results were able to go up to the desired figure of 93%. These findings are described as steel defect detection, but show that it will actually be possible to extract high accuracy data from various areas such as computer vision, NLP, and time series data. Additionally, he emphasized that the more data you have, the easier it is to filter out the noisy data, and the improvement in accuracy you get is much greater than when working with just a small amount of data. Andrew said that when there's about 10 to 15% of incorrect or inconsistently labeled data, which is called the noisy data, making a correctly labeled sample, collecting the sample data again, and removing the noisy data will improve the accuracy. So he says that higher level of accuracy can be achieved by running the test even with only a small sample. So from now on, I'm going to give you a technical explanation on how each solution has automated machine learning pipeline elements at DS2AI, which is a data-centric MLOps solution. So as we created the solution, we challenged three major missions. The first, we challenged the mission on how to build training data easily and quickly. Second, on how to develop artificial intelligence and to improve accuracy efficiently. And finally, we thought about whether we could quickly create artificial intelligence that could improve accuracy by easily deploying the developed artificial intelligence and connecting it to the retraining pipeline. Currently, many companies utilize labeling tools such as the one that you see on the left of the screen to secure training data and manually label them. And this labeling usually takes a lot of time and labor because the reality is that at least 10,000 to 100,000 annotated data must be present in order to build a model accurate enough to be in the production stage. So in order to reduce the number of operations, we are providing auto labeling services, which means that after creating artificial intelligence with minimal labeling data, the artificial intelligence labels it automatically instead of human beings. DS2AI conducted R&D to build an automation system that secures and improves a large quantity of data based on Andrew's research results. In fact, we decided that if AI could remove the noisy data while labeling additional data, it could bring data centricity work to life. So this is the labeling AI solution introduced in the demo talk, and it is the structure in which deep learning based AI automatically labels a large amount of data with only 10 to 100 sample labeling per class. Therefore, auto labeling can be divided into two main parts. The first is to create artificial intelligence with the label data, and the second is to auto label the data with the created artificial intelligence. At DS2AI, we create artificial intelligence with pre-acquired training data and use a technology called AutoML to train multiple artificial intelligence models, and then select the best artificial intelligence amongst them. Auto labeling will be conducted with the best artificial intelligence selected. So labeling is carried out with the developed artificial intelligence, and since this is carried out with less than 100 labeling data, it cannot produce high accuracy auto labeling results from the very beginning. So as the steps go on, the number of errors that needs to be checked gradually decreases and the accuracy improves. So the labeling algorithm upgraded automatically through the smart inspection system repeats the method of labeling new data again, saving time and labor costs dramatically, and has a structure in which accuracy converges towards 100% as the labeling of the same data group is repeated. Also, if we make corrections during the inspection process, there is a problem of consuming too much time revising it. So we enable quick inspection through the pass and reject process. And the pass data is used as training data. The rejected data would not be used. For these data, when the next round of auto labeling is performed, it will be fed into the process so that it can be repeated in such a way that it is inspected again with a higher accuracy model. Depending on the situation, we offer a variety of options, such as creating artificial intelligence while excluding the biased classes. And this is a result of data labeling of fire-related images among our client cases using labeling AI to which this design is applied. The accuracy of the model is confirmed to be between 97 to 100%. Fire image labeling model with an error rate of only 0.023% was created. Now let's consider that we've solved the labeling related mission so far and talk about the next mission, which is artificial intelligence development and the environment construction. So following Andrew's research results and to continue explaining Google's data, there are many issues that needs to be considered in the actual machine learning system. In fact, machine learning codes are only a fraction of the overall system of machine learning as shown on this page. The machine learning system actually exists at a system level, not at the level of machine learning code, which is actually a problem for the continuous introduction of artificial intelligence. In fact, AI does not end with the introduction and the application, but it is an important technology to continuously improve by reflecting the data that is constantly collected, because MLOps is an improvement system for continuous advancement in the process of introducing and applying machine learning and operating it. So now that we've looked at the high quality data we've obtained, Well, let's take a look at how DS2 AI creates and manages AI models. So first of all, in the AI development stage, we use a solution called Click AI. There are two options for artificial intelligence non-experts and for artificial intelligence experts. So Magic Code is an option for experts. The artificial intelligence development codes that fit the data set are automatically generated, making it easy to create AI models, easily modifying hyperparameters, and creating accurate AI. In addition, the DS2 AI SDK we provide is included. So the finished model has a system for verifying various models within our solution. Second option is for non-experts is to use our AutoML technology to automatically generate about 100 artificial intelligence models and return high accuracy models. As I showed you during the demo talk, users only need to choose the most accurate AI model by uploading the refined data through labeling AI, selecting a training method, and simply clicking a button. By automating the continuous feedback and test steps that require the most labor and cost in the traditional method, more efficient and rapid AI model development is possible. So how can we use the AutoML process to develop high accuracy AI? So we are using the multi-level deep learning system. DS2 AI's AI development process allows you to develop artificial intelligence by continuously repeating the testing of various hypotheses, discarding low accuracy test results, and searching for the optimal results. So to make this possible, we have adopted a way to make the solution work using all three frameworks, including TensorFlow, PyTorch, and Keras. Academic resources explain this structure in a way called permutation feature importance. So let me explain the structure of Click AI easily, assuming that it creates an AI model that predicts heights, human heights at the age of 20. There are useful variables in the data, such as heights at the age of 10, and variables with low explanatory power, such as socks owned at age 10. These variables are set not to be emphasized when describing the model. So permutation importance is calculated after model fitting is completed. Therefore, the created model cannot be changed, the target cannot be changed. Instead, asking the question, how will it affect the prediction accuracy by randomly mixing one column of validation data and leaving all the other columns in place. Right. So random rearrangements of columns no longer matches what is observed in the real world, resulting in poor prediction accuracy. In this case, shuffling the second variable, which is height at 10 years old, will significantly reduce the prediction accuracy. And shuffling the variable socks owned at age 10 instead has little effect in the prediction of results. Through this method, Click AI selects the most important variables. Based on the final predicted values, various AI is generated through analysis of importance of other training variables. The importance analysis method applies permutation differently to each training variable so that importance of the variables varies as the loss of the result value increases. Through this, different variables have different importance for each AI, and in this process, different weights are set to each variable in order to train artificial intelligence effectively. DS2 AI provides a service that allows you to analyze how various data and variables are used and various indicators are using the AI model created through this process. So in general, deep learning based artificial intelligence algorithms have a black box structure. So the problem of not knowing the internal progress is often it's a problem, but Click AI is an automated AI development function and an explainable AI, which allows experts to process the algorithm. It is designed to make it easy to check and respond to each variable. So if you look at this screen from the on the right side, there are various functions such as details, prediction functions, and analyze. Feature importance items show data with a high proportion used in the process of deriving the results. As shown in the previous model example for predicting heights. So in this model, bank deposit forecast project, it can be seen that the quarterly employment fluctuation rate has been selected as the most important variable. Based on this indicator analysis, it is possible to review and make a simple prediction that some variables need to be adjusted to produce other significant results. However, simple predictions alone are not enough to produce significant results. So Click AI informs you of what you have to do in order to achieve the desired results. So considering variables that can have a direct impact. So if you increase the number of employees who manage customers by 6.5%, increase the frequency of contact with customers by 5%, and finally contact them in May, it provides a guide that customers are about 77% more likely to use the bank in May. In addition, it helps management make decisions with as little risk as possible by telling them what additional variables to consider. Based on the bank deposit prediction project, it shows that in addition to the 3 variables previously selected, the consumer confidence index and the consumer price index can have a total impact of 10%. It can be applied in a form suitable for users by changing the variables used and using this function that allows them to check or modify the overall configuration and prediction values of the model. Confusion matrix function also exists. For an example, let's assume that you have created an AI robot that enters the recognized value when you display an alphabet. Because it responded with A when the letter A was displayed, we input the number 1 into the input and the output value A. This time when the letter B was displayed, the letter was broken, so it recognized it as D. In this case, number 1 is inputted accordingly to the input-output value of B and D. In this way, through a table that combines data and AI recognition results, it's the confusion matrix to see if the model works properly or if there have been any errors. So the confusion matrix can check whether the model is working properly or how many errors there are through the table that synthesizes the data and the recognized results of the AI. These indicators can be used to measure recall, precision, accuracy, F1 score, and etc. So once a model is created with Click AI, its own confusion matrix is created immediately this way, allowing you to intuitively grasp its contents. And in each of the kappa coefficient on the left here and the loss on the right, the reliability of the model can be determined through the indicator. You can see how reliable the model itself is and to what extent it is actually available to use. While the indicators introduced previously directly helped developers understand their models, Click AI also provides indicator analysis functions for data analysts and also scientists. Lastly, you can build a data pipeline for MLOps at DS2 AI with Python code. Through SDK, all functions from uploading the data to generating label to training and deploying artificial intelligence have been set up. Once you have completed the development of AI models using Click AI, SkyHub AI will provide integrated MLOps for the deployment, operation, and also the management of artificial intelligence. So not only artificial intelligence developed by DS2 AI, but also AI developed or operated externally can be managed with SkyHub AI as well. So for cloud versions, we support one-click deployment to AWS, Azure, and Google Cloud with the desired region, the desired server size, and performance. In addition, with our recently launched server installation type, we support this service in the form of direct deployment to backend endpoints within the server. So let's go ahead and take a look at the technology involved. So the biggest challenge we were given was whether we could provide a fast production level inference system, because the artificial intelligence inference function uses GPU memory and requires operation, delays can occur. In large-scale production level services, there will be many users. So when these delays overlap, it is easy to lag or cause some sort of memory errors to the extent that the service becomes impossible to use. Therefore, in order to reduce this delay, I'll go ahead and introduce the technologies we've adopted. The first one is TensorRT, which is a representative framework for weight reduction for accelerating AI reasoning. Basically, based on the ResNet 50, just using TensorRT on the same GPU improves performance by about 8 times. When we actually optimized the model, we were able to improve the speed from 1.5 times to as much as 10 times when the TensorRT engine was converted compared to the inference speed of PyTorch or TensorFlow models. Although there may be differences in performance depending on the model backbone, TensorRT was able to play a key role in terms of speed in order to deploy deep learning services. TensorRT automatically applies network compression, network optimization, and GPU optimization technologies to target deep learning models to ensure optimal inference performance on the NVIDIA platform. In this regard, let's look at the representative techniques used by the TensorRT to accelerate inference. So the first is quantization and precision calibration. Recently, precision reduction in deep learning training and inference has become almost a common method. The lower the precision network, the smaller the size of the data and smaller the number of bits of weights, enabling faster and more efficient operations. Among the quantization techniques for this, TensorRT uses symmetric linear quantization, which allows data of FP32 in the deep learning framework to be reduced to data types of FP16 and INT8. In general, reduction downscale to FP16 does not significantly affect the accumulation drop of the network, but the downscale to INT8 requires additional calibration methods because there are several types of networks showing accumulation drop. So TensorRT supports entropy calibration, entropy calibrator 2, and min-max calibrator, which can minimize loss of information on weights and intermediate sensors during quantization. Second is graph optimization. So in general, graph optimization is used to configure graph nodes in the form of a primitive operation. And compound operation used in the deep learning network optimized for each platform. And based on this, TensorRT applies the layer function method and the tensor fusion method at the same time. As you can see in this figure, the layer fusion is applied with vertical layer fusion, horizontal layer fusion, and tensor fusion to simplify the model graph, therefore reducing the number of layers in the model. Next is kernel auto-tuning. As mentioned earlier, TensorRT helps to create runtimes for NVIDIA's various platforms and architectures. Each product has different optimized kernels based depending on the number of CUDA engines, architecture, memory, and whether specialized engines are included. And dynamic tensor memory and multi-stream execution. In addition, there is a dynamic sensor memory function that helps to reuse by reducing footprints through memory management, and a multi-stream expansion function that can maximize the parallel efficiency through scheduling of multiple input streams using the CUDA stream technology. One of the features of TensorRT is that it also provides a Python API. So TensorRT was a good combination with a Python-based backend server that provides TensorFlow or PyTorch as a service. The system was also designed to work within our solution. We use a framework called Fast API for the backend server, and this Fast API framework provides compatibility with UV-Corn as a deployment function. This is equivalent to saying that if you're that you are using the fastest framework in Python. As I said before, the delay required when using the inference function is larger than expected. So reducing the delay in the backend server itself is one of the most important issues, as much as reducing the model weight. So we paid a lot of attention to this part. And the reason UV-Corn can be the fastest is that it is a super fast ASGI server using UV loops and HTTP tools. And the performance secret of UV loops lies in libov and Cython. Magic Stack, which is the group that developed UV loop, says it can achieve similar performance as Node.js and code. We use the Redis database on inference servers. And when we use inference servers on production level, we often get the same input value. Then we often return the same inference result. And whenever that happens, it's inefficient to use GPU memory and wait for inference results. As shown on this slide, it works by receiving the input value, storing the inference result as a key value together, and returning the inference result values stored in Redis without using GPU memory when receiving the same input value. Redis is a database that has the advantage of fast input and output speed instead of storing values non-permanently. If a regular database is a hard disk, memory key value data structure store, like Redis it would behave like a RAM. After deploying to this accelerated backend server, you can use the inference function directly in the UI or through the API or Python SDK to start the service right away. And after this, the inference result returned according to the input value stored in our data set. The stored inference result becomes training data that can be relabeled to create artificial intelligence. Currently, this deployment server provides not only the artificial intelligence models created in DS2 AI, but also the TensorFlow or PyTorch-based artificial intelligence models created by the users so that they can be uploaded and used immediately. The part that corresponds to the automated data pipeline shown earlier is the red circle here. So we are a solution that automatically builds such an automated machine learning pipeline. We can help teams of data scientists or data analysts who are spending a lot of time and money building these machine learning pipelines, since we have automated all data science related functions except data engineering. So we can help data scientists perform data science tasks with ease. So this concludes our talk on data-centric MLOps solution. Thank you very much for tuning in.